All right, good morning, everyone. This is week 7, classwork 18, solving compound interest equations. So our objective today is to be able to solve exponential equations from compound interest equations. So in the last video, we were solving exponential equations, so make sure you watch that first, okay? The do now is an example from the last video, so remember the process. Take a second to complete this on your own. Okay, so you should have completed that by now, and I'm going to bring back our process from yesterday just to review what we're doing here, okay? So, this is what you should have already on your paper. I'm going to go through this quickly. Isolate the exponent, done. Logarithm base 10 of both sides. Then I'm using my properties of logarithms. I'm bringing that exponent to the front. I have log base 10 of 10 equals the log base 10 of 250. And I know log base 10 of 10 is 1. So 1 times t is just t. And finally, I'm going to have to use my calculator to get an actual decimal answer here. So the way we do this, recall from last video. Make sure you've watched last video first. I'm going to use my number in the parentheses, 250, and then hit the log base 10 button. Okay, so I should have t equals 2.398. Rounding to the second decimal place is 2.40. All right, let's get into what we're doing today then. So, what we're doing is using our compound interest equations from last week. Okay, from the last 2 weeks, you're going to need to know your equations, these two equations, which are f equals p times 1 plus the rate to the time, or f equals p times 1 plus the rate over the number of compounding periods times the number of compounding periods times t. Okay, so if you need any help with these equations, go back to lessons 15 and 16. Okay? So what we're going to do here, let me read the instructions first. Dwight has $4,000 that he wants to invest in a retirement account. The account earns 8% interest per year. How many years will it take for Dwight to have $8,000 in the account? So what we're going to do here is write an equation and then solve for whatever variable we don't know. Okay, so we're going to determine the solution. We want to know how many years will it take for Dwight to have $8,000. So the first thing we need to do is determine which of these formulas we're using. Is this compound interest or is this a regular percent rate of change, right? So this is percent rate of change. And this is our compound interest equation. Okay, so what I'm going to look at is the units. So the account earns 8% per year, and how many years will it take for Dwight to have $8,000 in the account? Since this is years and years, we can use our regular percent rate of change formula. So we're going to start off with the basic formula, f equals p times 1 plus r to the t. Since this equation or this example does not say compounding, we're not using the compound interest formula. So that's the key word here. If we have a compounding period, we use the compound interest formula. If not, we're using percent rate of change. Okay, let me circle my last other numbers. He invests $4,000. The account earns 8% per year, blah, 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 blah. So we're going to be doing the exact same thing that we did in the lessons 2 weeks ago and 1 week ago, where we're going to substitute in our final value, our initial value, our rate, and our time. So, $4,000. Dwight has $4,000. We want to know how many years will it take for Dwight to have $8,000. So $4,000 is going to be P, the initial amount that he starts with. Okay? $8,000 is going to be F, the final amount that we want to figure out how long it takes to get there. 8% is going to be that rate. And remember, our rate if it's 8%, we need to divide 8 by 100 to get 0.08. Okay, so our rate is 0.08. Our P is 4,000. Our F is 8,000. And T is going to be the number of years. So we're going to need to solve for T. So let me substitute everything in. So we have 8,000 equals 4,000 times 1 plus 0.08 all to the T. Now we don't know what T is, so I'm going to leave T there. Now that we have this equation, this looks like something we did in lesson 17. So make sure you've completed lesson 17 first before this one. We're going to use our steps from lesson 17 to solve this equation. Okay? So step 1 from yesterday was to isolate the exponent. So just like yesterday, we're going to divide both sides by 4,000. And really, we know that this, we would rewrite this first. So we really have 8,000 equals 4,000 times 1.08 to the T. So we're simplifying first. Now we're going to isolate our exponent. Okay, so I'm going to divide both sides by 4,000. And 8,000 divided by 4,000 will be 2 equals 1.08 to the T. Okay, so now that I've isolated the exponent, I want to take the common logarithm of both sides. So I'll have the logarithm base 10 of 2 equals the logarithm base 10 of 1.08 to the T. Okay, I'm going to put my steps off to the side because you should have those written down somewhere. Now that I've taken the logarithm of both sides, I'm going to use my properties of exponents. I'm going to take this exponent, my properties of logarithms. So I know that log base 10 of 2 will equal, slide to the front, T times the log base 10 of 1.08. Okay? Then I want to isolate my variable. To get T by itself, I'm going to divide both sides by the log base 10 of 1.08. So then T will be equal to log base 10 of 2 over the log base 10 of 1.08. And I'm going to calculate those numbers in my calculator. So I'm going to do the 2. Log base 10 is 0.3010 all over 1.08. Log base 10 is 0.0334. And I'm going to divide 0.3010 divided by 0.0334, and I get 9.0119. So what we're trying to figure out here is how many years will it take for Dwight to have $8,000 in the account. We figured out T is 9.01 if we round, okay? So our answer will be 9.01 years if we're rounding to the second decimal place. And we need to have our units here because it's a word problem, right? We need to know what we're actually talking about. T is the time in years in this problem, okay? So what we're doing today is exactly like what we did in the last lesson. The only difference is that you have to set up your own equation, and then you have to have a unit in your answer, okay? So we're starting with a word problem. We write an equation. We follow all of our steps from yesterday in order to solve the equation, and then our answer has units, okay? I've got one more example for you of a different version, and then you've got practice on your own in the Google form, okay? So Pam is using a savings account that has an interest rate of 3.2% compounded every month. If Pam has $5,000 in the account after 6 years, how much money did she initially deposit? Okay, so let's first underline our question. How much money did she initially deposit? Initial deposit, we know, is our P value, no matter what equation we're using. So I'm going to just write that right off the bat. Okay, other keywords. Compounded every month. So now we know we have a compound interest equation. So I'm going to be using F equals P times 1 plus R over N to the N times T. Because it's a compound interest equation, compounded every month. Okay, what other numbers do we have? We have 3.2% rate. We have $5,000 in the account after 6 years. Okay, so let's start labeling these things. 3.2%, that means our rate is 3.2 divided by 100, right? Anytime we see that percentage, we know it's our rate, which is 0.032, okay? N, my compounding period, if we're compounding every month, my number of compounding periods is going to be 12 months divided by every 1 month. So how many months are in a year, right? We know that's going to be 12. So my N is going to be 12. If you need a refresher on how I got this, you need to go back to our compound interest lesson, okay? Because we spent a whole lesson on how to get N. Then we have $5,000 in the account after 6 years. And remember, whenever we do compound interest, T is always in years. So T, my T value is going to be 6 years. And my final amount, because we know we don't know the initial deposit, so the final amount is $5,000. Okay, so let's put all of this into our equation. We're substituting these values in. I'm going to have my final amount, $5,000, equals my present value, or not my present value, my initial value, 1 plus my rate over my number of compounding periods times my N to the N times T is 6. So let's simplify what we can here. So we have $5,000 equals P times 1 plus, I need to do 0.032 divided by 12, is 0.0027, we'll call it that, to the 12 times 6 is 72, okay? And we'll say 5,000 equals P times 1.0027 to the 72. Okay, so now in this equation, we need to solve for what variable? P. P is my only variable. We need to figure out how much money she initially deposited, which is P. In this case, since P is not an exponent, we can keep simplifying and solve for P using Algebra 1 skills, okay? So I can do 1.007 or 1.0027 to the 72nd power and get 1.2142, okay? So when I simplify this, I actually get 5,000 equals P times 1.2142. Can I solve for P now? Yes. How am I going to solve for P? If you said divide both sides by 1.2142, that's correct. I want to isolate my variable. So I'm going to do 5,000 divided by 1.2142. And I get that P equals 4,000, oops, you can't see that, $4,117.94. So this is how much money Pam initially deposited into her savings account. And then after 6 years, she had $5,000. Okay? So this is another way to solve these kinds of equations that we actually did not need to use logarithms for. So the key is, if you have a variable in your exponent, you'll need to use a logarithm. If your variable is not in your exponent, you should be fine, right? We were already doing problems where we were solving for f. Now we can solve for t, we can solve for p, we could solve for n. Well, no, we can't solve for n. That's actually a little harder. And then as a bonus, there's a bonus on how to solve for r. It's pretty cool. All right, so go ahead and do the classwork in Google Forms and let me know if you need any help.